Kia ora Year 12. This is the first video that I'm going to make in the holidays, and I thought we'd start with Nicholas's integral from yesterday's lesson. Now, when I got home, I realised that it's actually far easier than either he or I made it out to be yesterday. You don't need to do substitution first, and it actually makes it no better or even worse. You definitely don't want to do the thing that I tried in class, because we know that that went bad. But what we're going to do is first we're going to do our trig substitution here, using sine of 2 theta, and then we're just going to do integration by parts. And it really is just this time. Okay, so cleaning this up, we're going to get x times sine 2 ln x times 1/2 dx. Now the reason I need the 1/2 is that sine 2 theta is equal to 2 sine theta cos theta. Okay, so that's what I've applied there. So let's clean that up. Well, we've got a half times the integral of x sine 2 ln x dx. Right, now here's what I want you to try. Make this the bit that you integrate, and make this the thing that you either leave or differentiate. And you're going to have to do integration by parts twice, but we've done that quite a few times, so it's not too bad. So pause the video and then do it in your book, probably on a page that's not completely ruled up with a margin, because you're going to need quite a bit of width, and then I'll go through it on the next slide. Okay, let's have a look at how this goes. So we've got 1/2 times x sine of 2 ln x dx. We're going to do integration by parts. So it's going to be 1/2 times x squared on 2, and then we leave the next thing alone. So it's that minus 1/2 again, because of this. Integrate the x, and this time differentiate the sine and the function inside it. Now we're going to clean that up. So we're going to get x squared on 4 sine of 2 log x. Now what's next? Well, look here what happens. We've got a 2 here and a 2 here, and we've got an x here and an x squared here. So this is going to be minus 1/2 times the integral of x cos of 2 ln x. Now, if I were doing this in real life as a problem, I'd start to feel really happy about this point, because I can see that I'm probably going to get something similar, but bouncing back to a sine. So that's kind of my trigger that I'm going to be doing double integration by parts. But we're not quite there yet. So we've got 1/2 times this Right, so now we have 1/2 times x squared on 2, doing the same thing again, integrating that, and now leaving this. Minus 1/2 times the integral of x squared on 2, and this time I'm differentiating this function here, and that's going to give me negative sine 2 ln x times 2 over x dx. So where that gets me to is a very happy place. We've got 1/2 of this again. So we've got x squared on 4. Let's see, I'm just going to clean up those two terms there. X squared on 4 times sine of 2 ln x minus cos of 2 ln x. But look what's going on here. Well, I've got my 2 cancelling out, and this again. So this has got minus a negative times a negative, so that's giving me minus 1/2 x sine 2 ln x dx. Right, so what we've got is this is equal to this nice thing here minus this. So what we've got to do now is just to add that last term to both sides. So that gives me x, so 2 over 2 of them, 2 over 2 sine of 2 ln x dx is equal to x squared on 4 times sine 2 log x minus cos of 2 log x. Okay, so we did double integration by parts, and it worked out really, really nicely. Now the other interesting thing in there is that we've lost our constant of integration, which is kind of weird. So I haven't thought about that too much yet. It is the first day of the holidays. I think I've said that 4 times now. So you can ponder that for a moment and just see if you can think about what that means. Alright, there'll be another video tomorrow, probably slightly easier. What I'm going to try and do is to go through some old Pure 3 exam questions. If you've got any that you want me to do, just send me an email.